Hello everyone, welcome to Microsoft Build 2017. My name is Hariharan Jaraman. I'm a senior program manager in Azure Compute team, and today I'm going to talk to you about Azure Instance Metadata Service that can help your virtual machine instance bootstrap and also help with VM runtime. So let's get started. As you all know, virtual machines is just the starting point of your cloud journey. There is a lot to do beyond a VM. So when you start a VM, then you realize, oh, I need to think about virtual machine customization. What about my application customization running on that virtual machine? Do I need to worry about cluster setup? Like if I have a Hadoop or Cassandra cluster, do I need to think about how they will get set up? What about container placement? If I like my container technology, do I need to worry about where those containers get placed so that I get the best and highest reliability and availability for my system? Then I need to think about my services will have customer support. What kind of information does the support team need when they get a call about a VM? What about agent and server communication? How do I establish uniqueness from a virtual machine communicating back to a server? Application telemetry is another big area where you need to know uniqueness about different virtual machines that are communicating back to your service. And the same thing applies for network setup and network discovery. And finally, you would also want to know when there is a platform maintenance that happens underlying to your VM, how can you handle and maintain that? So let's take a look at what Azure Instance Metadata Service provides. First up, let's take a look at what the challenges are today. First up, all data regarding the virtual machines are behind an authenticated channel. What does that mean? That means in case of an automated setup, you need to provide credentials, and that can be challenging over time to maintain the life cycle of those credentials. All customizations need to be passed during the creation of your virtual machine. Ability to just in time know information about maintenance event is paramount, and today it's not present. And finally, also telemetry around your apps don't have a unique VM identifier. So how would you know how many VMs or which VM has a problem? And there are a few more. So let's take a look at what the Instance Metadata Service is and how it can help. A quick overview. The metadata service is nothing but a RESTful endpoint that your virtual machine can call into on a non-routable IP address local to the VM. This IP address is 169.254.169.254. A call to this address is responded by Azure's Instance Metadata Service from a cloud, and you will get information regarding your VM's compute, network, and upcoming maintenance events. It is a RESTful endpoint and it is exposed to all Azure Resource Manager created virtual machines. It is only available to a VM instance and is on a non-routable IP address. What that means is this is not a public interface. And at the end, no additional authentication is needed to talk to the service. So this really helps with the authentication not being a problem for automation scenarios. So let's take a quick look. I'll switch back into the Azure portal. In the Azure portal, I have created a few virtual machines. I'm going to take this virtual machine sample called IMDS sample. I'm going to SSH into it. I'm logged on to my Ubuntu VM. Now, the first thing I would want to know is if I didn't know what this VM was and I just got an SSH, how do I know which region it is in? So the first thing that I can do is to hit the metadata endpoint to get information about the VM. I'm going to take you through the pieces of the REST call. The first important thing to make this call is to pass a request header. This is required so that we know that it was an intentional call from the VM and not a redirect. We also intentionally disable X-forwarded calls to our metadata endpoint. The next is the IP address associated with the metadata service. And then we talk about the namespace of metadata And this is, since this is instance related information, we talk about instance. Also note that the API here is versioned, and the current version for preview is 2017-0301. And I'm just using JQ so that the output looks well formatted JSON. Entering this here will give you the entire metadata in one shot. This is unique because this allows you to make one call into the metadata endpoint and process all the data in one shot. We give you back in default JSON output, but we'll talk about what other formats are available. As you can see, the virtual machine VM is in West Central US, and I get other interesting information about the VM, specifically in terms of its name, the author, publisher of the image. As you can see, this is a canonical image, and I also get a unique identifier for the VM. This VM ID is a unique identifier that works against the lifecycle of your VM. Let's switch back and find out what else you can do. So from a developer application semantics point of view, the interface is RESTful in nature. It provides all interfaces for REST. It supports both JSON and text response. So as I was talking about, if you want a simple text response and you're using it via a bash script or a shell script, you don't have to go do the heavy lifting of parsing a JSON. But then again, given the advancements in Go and Python and Ruby, this is something that is quite easy to do now. It requires a request header. It is versioned, and every version is immutable. So in the sense that when you hit that version in any data center on Azure, you are guaranteed to get the same data set back. It is discoverable in nature, and also it is only responding back on a GET interface. So if you use POST, you will not get any data back. So with that said, where can I use this service? There are many different scenarios that I talked about when I started the journey about a virtual machine. Let's take a look at a few of them and see what we can do. First up, I want to talk about cluster setup. If you're using Cassandra or Hadoop or Mongo clusters in your cloud setup, you'll notice that to allow for high availability and reliability, you need information about the racks in which your VMs are placed. So where do I get the rack information about the VM? It's a simple call to the metadata endpoint, and that'll give you information about the fault domain, which is virtual rack information about your VM. And this information can be used for you to go and configure your cluster appropriately. So let's take a quick look as to how I was able to establish this on Cassandra. I'm going to go show you a rack-aware Cassandra demo on Azure. Going back to my portal, I was able to go and create a Cassandra cluster. But let's see how I did that. I used a simple Azure Resource Manager template to go and create a single DC Cassandra cluster, which is based out of the DataStax Enterprise GitHub repository. There's one simple change that I made to this template is providing the right information about the fault domain. How do I get the rack fault domain information? As you can see, during the node setup, I'm calling the metadata endpoint on Azure. This metadata endpoint responds back with the platform fault domain. And since I'm using shell script, I simply used text output so that I get a simple value back of the rack in which the node is going to be placed. How does this look like? Once the cluster comes up, it has many nodes. It has 6 nodes DataStax cluster. Once the cluster comes back up, you would actually see that the rack information is placed on per node basis. So if you go and click on a node, you actually see that this is fault domain 0, this is fault domain 0, but the other one is fault domain 1, fault domain 0, and so on and so forth. What this allows Cassandra to do is, whenever it is placing your database across these nodes, it makes sure that the replica set is spread across these racks. Coming back into another scenario, which is very useful from a support point of view. Imagine you have a support call of a service that you run in a virtual machine called Contoso service. the VM is not working, or your service within the VM is not working. The first thing that the support person would want to know is, hey, give me information regarding the VM, its size, the version information, etc. Where do you source it from? You can go to the portal and you can get some information about it, but specifics in terms of version, you would need to get inside the VM to get it. But then again, this information is spread across. Okay, let's take a quick look. This time, I've created a SQL Server virtual machine image on Azure. I'm going to connect to this and get metadata information about the VM. I'll remote desktop into my VM, and once the VM comes back up, I have a PowerShell window, and you can use curl, which is an alias to invoke web request, to get information about the VM's metadata. The call is very similar to what you have seen on a Linux machine. You simply pass the metadata header and call the compute specific part of the metadata, and you'll get the JSON back. As you can see, the system is running 2016 version of SQL Server, and specific version associated with this is also highlighted. This information is very powerful in the hands of the support team. One more interesting thing that I would like to point out to is we also provide the size. So this VM is running standard DS2, which is a fairly smaller sized VM for a big database. So if you can imagine, support could actually take a cue from this and find out what is possibly causing resource problems on this VM. Switching back, the next area that I want to talk about is managing planned downtime for your setup. An example here, I have a master-slave configuration of MySQL where an application is accessing this database. Now, what if I need to do a maintenance on the master? Typically, if I have to do maintenance on the master, I would have to take the master down, do a failover into slave, and then get my application to start running back again. Can this experience be improved on Azure? It certainly can. With schedule events, it's another service that's a part of the Azure Instance Metadata Service. It provides just-in-time information for an upcoming planned maintenance event. It's a RESTful call to know if there is an upcoming maintenance event for your VM. You can get up to 15 minutes to do an in-VM action before the action actually takes place. Let's take a quick look. So back to the Azure portal, I have the MySQL replication already set up. I have a master and a slave and the load balancer in front that makes sure that our traffic is routed appropriately. Let's take a look at the master itself. I'm connected via SSH to the master database, and in here I have a script called scheduleevents.py. This script could be run as a cron job. All the script is doing is monitoring for schedule events at this address. As you can see, it's again under metadata /schedule events. In here, as I get a schedule event, I parse that event out, and once this is done, I send a response back that I'm ready for a reboot, and I also call into the slave to failover to slave. Right? This allows me to failover to slave and make slave the master. Let's see this in action. So I'm going to start my script, and I'm going to go into portal and simulate a failure. So I'm going to go to my master and restart the master. Going back to my shell, right now I don't see any events coming back, but as this event appears, I'm going to actually see this event, register this event, and post that I'm going to act and allow for failover to happen. Once the portal goes through the restart process and allows this to come down, this is going to go down and get me an event. So while this event comes through, let me show you what's happening on the slave side. When I call failover choose slave, all I'm doing is updating the load balancer event, and then I'm using the Azure CLI to be able to change the load balancer setting and update the SQL Server setting to make itself the master. This is one of the simple ways I can actually go and establish high availability for half or even 1/4 of the cost of running HA proxy setup for MySQL on Azure. Moving forward, let's talk about where all this service is going to be available. The service is currently available in West Central US region of Azure. Please feel free to give it a try on the service and give us feedback at feedback.azure.com or send us a mail on azureimds@microsoft.com. And finally, talking about the general availability. We're working hard to meet the service goals, and the service will be made generally available in the upcoming months. To learn more about metadata service or schedule events, you can look at these documentation available at docs.azure.com. Finally, as a parting sample, we want to also talk about samples that you can leverage for your own setup for both metadata as well as schedule events. So here are some samples of quickly getting metadata via curling at the metadata endpoint. There's also GitHub samples for both schedule events in Microsoft samples, as well as the Cassandra node setup for rack awareness that I showed. And finally, regarding the roadmap, we have a couple of more data elements that we're going to work on for the upcoming releases. If you feel that you need additional data elements to make your life easier on automating a virtual machine, send them across to us using azureimds@microsoft.com or send us a feedback at feedback.azure.com. Thank you so much for your time. I'm looking forward to hearing from you.